Okay, so we are on lesson 2, which we're going to talk about multiplying powers with the same base. But before we do that, I'm going to show you again some patterns here of how or why we can do this rule of multiplying powers with the same base. So for example, if I had 3 squared times 3 to the third power, okay, well that is the same as doing 3 squared is a 3 times a 3, and then times 3 to the third power is a 3 times a 3 times a 3. So that's essentially the same as a 3 to the 1, 2, 3, 4, 5 fifth power. Okay, what really happened is since both of these had the same, this is called the base, both of these had a base of 3, what we did was we kept our base of 3, but we added our exponents to get our final result. And that's exactly what it will be when we are doing these problems of multiplying powers with the same base. What we do is we add our exponents. But again, the thing is they need to have the same base. So if you have an a to the mth power times an a to the nth power, since both of these have the same base of a, then we can do an a to the m plus n power. But if I had an a to the m power times a b to the n power, that is not going to be equal to an ab to the m plus n power. We cannot do it when we have different bases. But if we have the same bases, we add our exponents. And then remember our other rule of if it's 0 as an exponent, then your value is just 1. And if you have negative exponents, what are you going to do? All right, so we're going to simplify each expression. This means no negative exponents. So for number 1, what we want to do is we want to multiply the coefficients together. So my coefficient of my first one is 5. My coefficient of my second one is 1. A 5 times a 1, you can always multiply numbers together in coefficients. So 5 times a 1 is a 5. And then now I'm going to multiply the c to the 4th power times the c to the 6th power because they have the same base of c. And how I do that is I keep my c and I add my exponents. 4 plus a 6 is a 10. So I have a 5c to the 10th power, and that is fully simplified. Now on number 2, same thing. I'm going to multiply my coefficients. So 7 times an 8 is a 56. And now I'm going to multiply my x's. An x to the 5th power times this is technically an x to the 1st power. They have the same base of x, and I add my exponents. A 5 plus a 1 is a 6. So I have an x to the 6th power. And that is fully simplified. All right, my next one, I have a negative 2 times a 3.5. I'm multiplying my coefficients, and I wind up with a negative 7. And then I have an m to the 3rd power times an m to the negative 3rd power. Since they have the same base of m, I add my exponents. A 3 plus a negative 3 is really a 0. Now this can be simplified further. This negative 7 it doesn't have a negative exponent. So some of you guys might have been thinking, oh, let's move this negative 7 into the denominator and make it positive. No, you can only move things if it has a negative exponent. Technically, this negative 7 has an exponent of positive 1, so it will stay where it's at. It stays in the numerator. And then an m to the 0th power is just a 1. So I really have a negative 7 times a 1, which is just a negative 7. And negative 7 is your answer. All right. Number 4, both of the coefficients on these two things are 1. So we don't have to worry about multiplying the coefficients because a 1 times a 1 is just a 1. So I'm going to start multiplying now the variables. An a to the 6th power times an a squared. Since those have the same base, I keep my base of a, I add my exponent of 8. And then a b cubed times a b to the negative 2nd power. I keep my b. I add my exponents. A 3 plus a negative 2 is a 1. If you want to write the 1 in, you can. You do not need to, but there's no negative exponents there, so that is fully simplified. All right, next one. I have a 1 over, and then now I have an a to the 4th power times an a to the negative 3rd power, which they have the same base, so I add my exponents, so I wind up with an a to the 1st power, which again, you can write your 1 exponent, or you can just leave it as an a. It does not matter. There's no negative exponents there, so I'm good. I just leave it like that. And then lastly, my next one, an x to the 1/3 power times an x to the 2/3 power. I keep my base of x, I add my exponents. A 1/3 times, or plus a 2/3 is a 3/3, and a 3/3 is really an exponent of 1. So this is really an x to the 1st power, or just an x. No negative exponents there, so that's fully simplified. All right, so that's what we do when we're multiplying powers with the same base. You add the exponents. Now what we're going to do, raising expressions to a power. So you're going to raise, if we have 2 factors in parentheses with an exponent on the outside, both of those factors will get that exponent. So the a and the b will get the exponent of p. That's what it means when I say raise each factor to the power. And then the other part where it says multiply the exponents, well, a already had an exponent attached to it, which was m. And if I'm going to put this p exponent in to the a, then I need to multiply the m and the p together. And same with the n exponent attached to my b, I would need to multiply the n and the p exponent together. So I know that that was a lot of information, but we're going to get through that together. Essentially, any exponent that's in the outside of parentheses will just be, I don't really like to use the word distribute in this case, but technically that's what we're doing. We're distributing that exponent in. So this exponent of 8 on the outside will be distributed into the n to the 4th power. And in this situation, what we do is we multiply our exponents. So up here in these situations, we added the exponents. This time I'm raising an exponent to an exponent, a power to a power. So I multiply my exponents together. So I would have an n to the 32nd power, and there is no negative exponents there, so that just stays there. All right, next one, I'm going to raise the x to the 3rd power to the negative 5th power by multiplying my 2 exponents together, so I get an x to the negative 15th power. Now to simplify means that I should have no negative exponents. So I need to take this x to the negative 15th power and move it into the denominator, which would leave a 1 in the numerator and then an x to the positive 15th power in the denominator. And now that's fully simplified because I don't have negative exponents there. All right, the next one, a z to the 8th to the 0th power. I'm going to multiply these 2 exponents together, and 8 times a 0 is a 0. So I have a z to the 0th times a z to the 5th. What I do here, this is different because I'm not doing an exponent to an exponent. I have 2 of the same bases being multiplied by one another, so in this situation I add my exponents. A 0 plus a 5 is a 5, so I have a z to the 5th power. All right, next one. I have a c to the 3rd to the 5th, so I'm raising an exponent to an exponent, which means I multiply those exponents together. And a d to the 3rd to the 0th, I multiply those exponents together too to get a d to the 0th power. Now a d to the 0th power, anything to the 0th power is just 1, so that cancels out because a c to the 15th power times a 1 is just a c to the 15th power. So that is fully simplified now. All right, next one, an m to the 3rd to the negative 1st. Well, I'm going to multiply those exponents, so I get an m to the negative 3rd power, and then an x squared to the 5th, I multiply those 2 exponents, and I get an x to the 10th power. Now the m to the 3rd power has a negative exponent, so that's going to need to go into the denominator, where my x to the 10th power will remain in the numerator because it already has a positive exponent. So this is your final answer for that one. All right, the next one, both the 7 and the a are going to get this exponent of negative 2. We're going to distribute that in. This is a big mistake that students like to make. A lot of students say, all right, well, a 7 to the negative second power is a negative 49. No, a negative exponent never makes your number negative. What we do with a negative exponent is we move it to the denominator. So the 7 to the negative second should get moved, and the a to the negative second should get moved, which means I'm going to be left with a 1 in my numerator, and then I have a 7 to the positive second, a to the positive second in the denominator, which I can simplify a 7 to the second because that's a 49. You could do that in your calculator if you did not know. Remember how I do the little caret button, 7 and then the upwards arrow and then a 2. That will give you the 49. All right, so now looking at number 13, I'm going to distribute this exponent of negative 3n. So I have a 2 to the negative third, y to the negative 12, because I multiply those exponents. Now I'm going to need to send both of these down into the denominator because they both have a negative exponent. So I wind up with 1 over 2 to the positive third and y to the positive 12. Well, I can do a 2 to the positive third power. I get a 1 over a 2 to the third power is the same thing as an 8, and then y to the 12. That is fully simplified now. All right, the next one. Probably shouldn't have put this one in here, but let's just roll with it. So I get a 36 to the negative 1/2 power, and then a g squared. And the reason why I shouldn't have put this in here is because, sorry, that should be a g to the negative second. So now all of these are going to go into the denominator. So I wind up with a 1 over a 36 to the positive 1/2 power and a g squared, which we haven't learned this yet, but 36 to the 1/2 power is the same thing as the square root of 36. And the square root of 36 is 6, which we'll learn how to do that a little later. So I promise I won't give you any like this on your homework. But this should be a 1 over 6g squared. If you already know how to work with square roots, then great. All right, the next one, an x to the 2/5 to the 10th power. So I do need to multiply these two exponents together. So I get an x to the, this would be the a 20 over 5th power because we do the 2 times the 10. And so a 20 divided by a 5 is a 4, so I wind up with x to the 4th power as my answer. All right, and then the next one here, I wind up with a 4xy squared, and a 0 to the 4th power is a 0, and then times a negative y to the negative 3rd power. Well, you guys should have noticed something, that we have this 0 here. And a 0 times anything is 0, and this 0 is being multiplied by this first half and by this last half, so 0 times all of that would just wipe out the whole answer to 0. And then number 17, I have a 3 to the 7th to the 2nd, so I'm going to multiply those exponents to get a 3 to the 14th. And then I have a 3 to the negative 4th to the 3rd, so multiplying those exponents, I get 3 to the negative 12. Now I have the same base. I'm going to keep that base and add my exponents. A 14 plus a negative 12 is a 2, and then I actually can do a 3 squared. A 3 squared is a 9. All right, that brings us to the end of lesson 2. You will need to move on to lesson 3. Which now we're going to be dividing powers with the same base.